Before we explore the recent announcement, it's crucial to understand the technology behind it. Particle accelerators. The Large Hadron Collider, LHC, operated by CERN, is a 17-mile ring of superconducting magnets and stands as the largest and most powerful particle accelerator on Earth. This colossal machine is a marvel of modern science, capable of recreating conditions that existed just moments after the birth of the universe. But could this instrument, designed to unravel the deepest secrets of reality, also be a gateway to something far more unsettling? CERN, established in 1954, is one of the world's most prestigious scientific institutions. With 23 member states and thousands of scientists, it serves as a global hub for cutting-edge research and international collaboration. At the heart of its endeavors lies the LHC, CERN's crown jewel, but it's just one component of an intricate web of accelerators and experiments. Picture a racetrack, not for athletes or cars, but for subatomic particles. In this race against time and space, the LHC hurls protons to nearly the speed of light, sending them on a collision course that mirrors the energy conditions of the early universe. These collisions generate temperatures over 1 million times hotter than the sun's core. Thousands of precision-engineered magnets guide the protons, while ultra-cold systems keep the machine operating at temperatures colder than deep space. The protons smash together at 4 key points along the ring, where massive detectors, ATLAS, CMS, ALICE, and LHCb, capture the resulting data. Each detector focuses on a different frontier of particle physics. Together, they function like immense high-speed cameras, capturing subatomic wreckage in astonishing detail. From this chaos, scientists hunt for signs of the elusive Higgs boson, dubbed the God particle, and other phenomena that may hold the key to understanding dark matter and the forces that shape our universe. By probing the tiniest building blocks of matter, researchers hope to gain insight into the cosmos itself. Yet, every breakthrough brings new mysteries, and with each step forward comes a new set of challenges. The LHC isn't just a tool of science. It's a monument to human curiosity. It represents our tireless drive to uncover the truth and understand the forces that govern reality. But pushing the frontiers of knowledge also means confronting profound ethical and existential questions. What are the risks of delving into the unknown? Could we inadvertently unleash something we can't contain? In the halls of CERN, where the limits of human understanding are constantly tested, a recent revelation has stirred unease, even among the most seasoned scientists. Physicist Brian Cox, a former CERN researcher and prominent science communicator, has made a statement that captured global attention. With chilling clarity, he confirmed that one of the LHC's primary goals is to recreate a mini Big Bang. Yes, you heard that correctly. Scientists are attempting to replicate, on a small scale, the very explosion that gave birth to our universe. Cox elaborated on the significance of this goal, highlighting the LHC's incredible potential, not just in revealing the properties of the Higgs boson, but in unlocking the mysteries of dark matter, a substance that makes up much of the universe but remains invisible to us. To hold the power of creation in our hands, to summon the conditions of cosmic birth, is both thrilling and terrifying. The mini Big Bang is not just a theoretical dream. It is a physical event happening within the LHC. The energies, pressures, and heat mimic the dawn of time itself. It's like standing on the edge of existence, watching the universe take its first breath. But with such power comes responsibility and risk. History has already offered a sobering reminder of what can go wrong. In 1978, Russian physicist Anatoly Vygotsky suffered a catastrophic accident while working on a U-70 synchrotron in Prop Vino. A malfunction caused his head to be struck directly by a proton beam. The beam, carrying incomprehensible energy, entered the back of his skull and exited through his nose. The incident defied belief. Vygotsky saw a flash brighter than 1,000 suns, but felt no pain. The beam carved a path through his brain, causing lasting damage, including hearing loss and partial facial paralysis. Yet, astonishingly, he survived and continued his scientific career. Vygotsky's story is both haunting and awe-inspiring, a human reminder of the immense power these machines wield. Otherworldly, he witnessed a flash brighter than 1,000 suns, yet felt no pain. The beam carved a path of destruction through tissue and bone, but remarkably, he remained conscious and even walked to a clinic on his own. The aftermath was both terrifying and fascinating. The beam's trajectory caused localized tissue death, resulting in partial facial paralysis and hearing loss in one ear. Astonishingly, however, Anatoly Bugorsky's cognitive abilities were untouched, and he continued his scientific work. His ordeal is more than a personal tragedy. It's a stark reminder of the raw, untamed power of particle accelerators. Machines like the Large Hadron Collider, LHC, aren't just marvels of modern science. They carry risks that should not be underestimated. Some physicists have raised serious concerns. The possibility of triggering unknown reactions, manipulating the very fabric of space-time, and yes, even the creation of microscopic black holes. Black holes are regions of space-time where gravity is so intense that not even light can escape. Often described as cosmic vacuum cleaners or devourers of stars, they represent some of the most mysterious entities in the universe. The thought that the LHC might generate such a force, even on a minuscule scale, has alarmed both experts and the public. Could a black hole created in a lab grow uncontrollably, devouring the Earth from within? CERN scientists assure that any such black hole would be unstable and would evaporate almost instantly via Hawking radiation. Yet, the mere possibility has sparked heated debates, fears, and a deep sense of awe about the power we now possess. Understanding how the LHC might create a black hole requires a look into mechanics of high-energy collisions. When protons are smashed together at near light speed, the resulting energy is so intense that it can warp space-time itself, like a heavy object deforming a tightly stretched trampoline. If the conditions are right, the deformation could be so extreme that a tiny gravitational well, a microscopic black hole, could briefly form. In the realm of quantum physics, where reality often defies intuition, theories suggest that hidden extra dimensions might exist. If so, the LHC's collisions could momentarily access these dimensions, funneling energy into a point and creating a black hole. This dance of subatomic particles hasn't gone unnoticed by prominent scientists. The late Stephen Hawking warned in his writings that the Higgs boson at extremely high energies could become unstable. This could theoretically trigger a catastrophic vacuum decay, a chain reaction that might annihilate not just Earth, but the entire universe. Sir Martin Rees, renowned British cosmologist, echoed these concerns in his book on the future, Prospects for Humanity. He explored not just theoretical risks, but assigned probabilities, however low, to scenarios like vacuum instability. Rees warned that an errant experiment could initiate a phase transition, a shift in the universe's fundamental state, with apocalyptic consequences. Though such outcomes are improbable, Rees argued that even a tiny chance should compel deep caution. The margin for error is vanishingly small, and the potential cost is beyond comprehension. CERN scientists have conducted extensive risk assessments, simulations, and peer-reviewed studies to ensure the LHC operates safely. Physicist Brian Cox has acknowledged the seriousness of public fears, emphasizing that strict safety protocols and exhaustive review processes are in place. The pursuit of discovery must be responsible and never blind to its potential consequences. Cox emphasized that the experiments are conducted with extreme precision, reassuring the public that the energy levels involved are well within what Earth naturally experiences. The likelihood of producing a stable black hole, he explained, is astronomically small. Even in the rare event one did form, it would be minuscule and highly unstable, vanishing almost instantly in a burst of energy through a process known as Hawking radiation, as predicted by Stephen Hawking. Such an event would be a fleeting spectacle, a brief glimpse into the unknown, gone in an instant. Yet speculation persists. Some imagine the LHC might do more than recreate conditions from the dawn of the universe. They wonder, could it tear open a portal to another dimension? Could it unlock pathways to alternate realities? Though dismissed by the scientific mainstream, these ideas have gripped public imagination, becoming fuel for science fiction, internet lore, and even fears of apocalyptic outcomes. The media has sensationalized the possibility, however improbable, of the LHC becoming a gateway to hell, stoking intrigue and unease alike. But where did such a notion originate, and how does it align with real science? In theoretical physics, the concept of parallel dimensions is not mere fantasy. String theory, a leading framework in the quest for a unified theory of everything, suggests the existence of additional dimensions beyond the familiar three of space and one of time. These extra dimensions may be compactified or hidden from our senses, but could, in theory, be revealed under extraordinary conditions. Now imagine the LHC as a cosmic key, turning the lock on ancient doors sealed since the birth of the universe. When protons collide at unprecedented energies, the very fabric of reality is stretched, challenged, and perhaps, just perhaps, parted. Could these collisions briefly reveal realms beyond human comprehension? While the probability is infinitesimal, the idea lingers. What if the LHC doesn't just deepen our understanding of the universe, but shifts our entire perception of reality? Could we be standing at the threshold of a discovery that redefines existence itself? As the world watches, entranced by this monumental experiment, the promise of discovery remains boundless, and so, too, does the shadow of potential peril. The LHC is a marvel of human ingenuity and a beacon of scientific progress. It holds the power to unravel mysteries that could transform our understanding of the cosmos. Yet with such power comes immense responsibility. We must confront the ethical challenges and potential unintended consequences of venturing into the unknown. The central question remains, are we truly prepared for what we might uncover at the heart of the LHC? And if we are, how will we wield that knowledge? The answers may shape not just our scientific future, but the fate of our very reality.